Hi, this is the sixth subtopic of chapter 1, Precalculus, and the topic of this subtopic is absolute value functions. At the end of this section, we can graph absolute value functions and we can solve absolute value equations and absolute value inequalities. So, what is absolute value? Absolute value is the distance the number is from 0 on a number line. So if I draw a number line 0, 1, 2, 3, negative 1, negative 2. Absolute value of 3 is how many units is it far from 0? 3. Absolute value of negative 2 is 1, 2. 2 units far from 0. 2. Absolute value of negative 1 is 1. So no matter what number we put in absolute value, the result is always, outcome is always positive. Absolute value of negative 100 is 100. Absolute value of 100 is 100. We can define absolute value as a piecewise function. So f of x is equal to x if x more than or equal to 0 and negative x if x is less than 0. Absolute value of 4 is equal to 4. So absolute value of x is equal to x when x is more than or equal to 0, this case. Absolute value of negative 4 is equal to negative 4, which is equal to 4. When x is negative 4, then the answer is negative x. Describe all values x within or including a distance of 4 from 5. So if I have a number line and 5 is here, x can be anywhere 4 units far from 5. 4 units, 4 units. So here we have 9, here we have 1. So x can be anywhere within the 4 units far from 5. That means distance of x from 5 is less than or equal to 4. If it's on the right side, then x minus 5 is less than or equal to 4, and if it's on the left side, then it is more than or equal to negative 4. And if we solve this, x will be less than 4 plus 5 and more than or equal to negative 4 plus 5. So x is between 9 and 1. Describe values of x within a distance of 3 from number 2. So we can pause the video and try to solve this one. So we want to describe numbers 3 units far from 2. So 3 units right, 3 units left, 5 and negative 1. So basically absolute value of x minus 2 is less than or equal to 3. Then absolute value of x minus 2 less than 3 and more than or equal to negative 3. So x is between 3 plus 2 and more than or equal to negative 3 plus 2. So x is between 5 and 1, negative 1. Here we have an example. Suppose we have a resistor rated 680 ohm plus minus 5%. So this is variation. Companies that design resistors cannot be very exact, so they give variation. For example, the resistance of this resistor is between 680 plus 5% and 680 minus 5% of 680. So 5% of 680, what is it? 5 over 100 times 680 is equal to 34. So the resistance is between 680 plus minus 34. 680, 34 units to our right and 34 units to our left. The resistance could be any number between these numbers. If we call it R, then R can be anywhere here. So we can write R minus 680 is less than or equal to 34. Students who score within 20 points of 80 will pass a test. Write as a distance from 80 using absolute value. So if 80, then 20 units right, 20 units left. Scores within this interval are passed, so that's actually 60 and 100, between 60 and 100. So let's say score of student is S. S can be anywhere between 60 to 100. So S minus 80 absolute value is less than or equal to 20. So graphing absolute value. We are familiar with the graph of absolute value of x, and you can give points if you want and see if it's like this: x, y, negative 2, 2, negative 1, 1, 0, 0, 1, 1, 2, 2. So 0 and 0, 1 and 1, 2 and 2, negative 1 and 1, negative 2 and 2, and connect these points. Now we want to graph this one. Y is equal to 2 absolute value x minus 3 plus 4. So here is absolute value of x. Absolute value of x minus 3, remember if x minus k, k is 3, is positive, so we just shift this graph 3 units to our right. Absolute value of x minus 3, here it is. Then 2 absolute value of x minus 3. So b f of x, b is more than 1. That means it will be compressed with a factor b. So x variables don't change, y variables will be double. So here we have 4 and 1. 4 and 1, we go to 4 and 2 times 1. 5 and 4, 5 and 2, we go to 5 and 4. So here is 2 absolute value of x minus 3. Then plus 4. So from f of x plus k, when k is positive, we shift up. So 4 units, 1, 2, 3, 4. 4 units we shifted up. Y is equal to 2 absolute value of x minus 3 plus 4. Write an equation for the function in the figure. So from the figure we can tell that this graph belongs to absolute value of a function because of this corner point. So let's draw the graph of absolute value of x. Here is absolute value of x. So we shifted 3 units to our right and 2 units down. So 3 units to our right and 2 units to our down. So the graph was also compressed, like if you 3 to 4 in this 1 unit. For this graph, y is 1 unit, but for this one, same width, 2 units. That means f of x was multiplied by 2. So 2 of f of x is this graph. This graph was absolute value of x 3 units toward right, so x minus 3. 2 units toward down, so minus 2, and times 2. For real numbers a and b, absolute value of a is equal to b if b is greater or more or equal to 0, then a is equal to b or negative b, and if b is less than 0, absolute value of a is equal to b has no solution. For example, if absolute value of x is equal to 4, then x is 4 or negative 4 is equal to 4 or plus minus 4. It can be 4 or it can be negative 4. But if b is less than 0, for example, absolute value of x is equal to negative 5, then it's impossible. Absolute value is always positive, so it has no solution. For the function f of x is equal to absolute value of 4x plus 1 minus 7, find the value of x such that f of x is equal to 0. So absolute value of 4x plus 1 minus 7 is equal to 0. That means 4x plus 1, absolute value of 4x plus 1 is equal to 7. So 4x plus 1 is equal to 7, or 4x plus 1 is equal to negative 7. From solving this one, 4x is equal to 7 minus 1, 6. So x is equal to 6 over 4 is equal to 3 over 2. And here 4x is equal to minus 7 minus 1 minus 8. So x is equal to negative 2. So for x is equal to 3 over 2 and x is equal to negative 2, f of x is equal to 0. And if we graph it, we can see that negative 2 and 0, one answer, and another one, 1.5 and 0. For the function, find the value of x such that f of x is 0. So again, absolute value of 2x minus 1 minus 3 is equal to 0. Absolute value of 2x minus 1 is equal to 3. So 2x minus 1 is equal to 3, or 2x minus 1 is equal to negative 3. From here, 2x is equal to 4, so x is equal to 2. and from here 2x is equal to -2, so x is equal to -1. So we have two answers. Solve 1 is equal to 4, absolute value of x minus 2 plus 2. So 4 absolute value of x minus 2 plus 2 is equal to 1. Then 4 absolute value of x minus 2 is equal to 1 minus 2. So 4 absolute value of x minus 2 is equal to -1. So absolute value of x minus 2 is equal to -1 over 4. Because absolute value is equal to a negative number, so no solution. In example 1.73, if f of x is equal to 1 and g of x is equal to 4 times absolute value of x minus 2 plus 2, would they intersect? No, because this has no solution, so they do not meet each other. If there was a point that they intersect, that point would be the solution, the answer of the question. Find where the graph of function f of x intersects horizontal and vertical axis. Where does the graph meet x-axis and where does it meet y-axis? So x is equal to 0, then f of 0 is equal to -0 plus 2 plus 3 is equal to 1. So 0 and 1. This is where it meet y-axis. If you want to graph it, this was one point that the graph meets y-axis. And if we want to find x intersection, then y will be equal to 0, or f of x will be equal to 0. Then what is x? So negative absolute value of x plus 2 plus 3 is equal to 0. Negative absolute value of x plus 2 is equal to -3. So x plus 2 is equal to 3. So x plus 2 is equal to 3, or x plus 3 is equal to -3. In this case, x is equal to 1, or x is equal to -6. So 2 points. One is 1 and 0. Another point is -6 and 0. 1 and 0, -6 and 0. These are the points that the graph intersects this y and x axis. So the graph will look like this. Now we want to learn about inequality involving absolute value. So we have 4 situations. These two are very similar, and these two are very similar. So when absolute value of A is less than B, or less than or equal to B, then A is between B and -B. When absolute value of A is more than b or more than or equal to b, then a is more than b or a is less than or equal to negative b. Example. So this one, absolute value of a is less than or equal to b. So x minus 5 is between 4 and negative 4. So x is between 4 plus 5 and more than or equal to negative 4 plus 5. So x is less than 9 or equal to 9 and greater than or equal to 1. So let's say another example. Absolute value of x minus 5 more than or equal to 4. How can we solve this one? So this one was less than or equal to 4. This one is more than or equal to 4. In this case, x minus 5 is more than or equal to 4, or x minus 5 is less than or equal to negative 4. Here, x is more than or equal to 9, or x is less than or equal to 1. And if you want to show them on number line, this will be 9, 1. This is 9, 1. More than 9. And less than 1. So here is the graph of absolute value of x minus 5, and this one is g of x, which is equal to 4. Now we want to solve this equation. So absolute value of x plus 2 is less than 6. So x plus 2 is less than 6 or equal to 6, and more than or equal to negative 6. So x is less than 6 minus 2 and more than or equal to negative 6 minus 2. So x is between 4 and more than or equal to negative 8. Another one, given function f of x, determine x values in which function values are negative. What should be put in x? F of x is less than 0. So negative 1 over 2 4x minus 5 plus 3 is less than 0. So negative 1 over 2, absolute value of 4x minus 5 less than negative 3 times negative 2 times negative 2. So it will be absolute value of x minus 5 more than 3 times 2, 6, negative 3, and multiply both sides by negative 2. Then, because I multiplied both sides by a negative number, I changed the direction of inequality. 3 times 2, 6. So in this case, 4x minus 5 is greater than 6, or 4x minus 5 is less than negative 6. From here, 4x is more than 6 plus 5, 11. So x is greater than 11 over 4, or 4x is less than negative 6 plus 5. 4x is less than negative 1, so x is less than negative 1 over 4. And here is the graph. x more than 11 over 4, which is 2.75, and x more than negative 1 over 4, which is negative 0.25.